Welcome everyone to session ARC 205 on remote workforce cloud migration patterns. I'm Jennifer Hagenba, a solutions architect at AWS. With me on this session is John Walker, also a solutions architect at AWS. We're excited to be joining you today from her home offices to talk to you about major solutions for your remote workforce and how to migrate these solutions to AWS. We know that you probably joined today's session to learn about remote workforce cloud migration patterns, and we promise you wouldn't be disappointed. John and I are both part of our small and medium business segment on AWS. More than 50% of our work deals with migrating workloads, and very often we're talking to different customers about migrating their remote workforce solutions from on-premises to AWS. So let's get started. So if you think about how many organizations have had to switch to working remotely in the past year or two, many fall into that category. The workforce has been changing for a while, and recent events have only accelerated those changes. For example, before the pandemic, 1 in 5 jobs in the US was held by contractors, and 70% of users globally were already working remotely at least one day a week. Deloitte's annual activity report at Global Mergers and Acquisitions also show that 79% of organizations expect to increase M&A in 2020. So if you take a look at these long-term trends, it's more important than ever to start planning your workforce transformation to deliver solutions for your remote staff and to ensure that you enable agility, continuity, and security for your remote workforce. So in essence, what we see is that this could create some challenges for your entire organization, whether that means you have call center agents that can no longer go into the physical contact center, but still need to support customers remotely, or maybe you have employees that need to remotely communicate and collaborate via chat or messaging solutions with each other to remain productive and feel connected. Your employees may also need to use virtual desktops or streaming applications without the need for PCs or laptops. With all of these in mind, we thought we'd share with you today 4 major remote workforce solutions on their key migration architecture patterns, whether that's your call center agents, employees, or students and educators. Here are the key takeaways from this session. We'll cover 4 main remote workforce solutions. And for each remote workforce pattern, we explore the deployment paths and migration approach using the AWS well-architected principles. So keep in mind that this session is a 200-level talk today in the sense that we're not going to dive deep into the solution architectures, but we are going to see some really cool stuff about migration methodology and architecture best patterns. We'll also cover customer examples and share additional resources as we explore each remote workforce solution. AWS offers several services to enable remote work and learning, and these are full solutions we'll be talking about today. We'll talk about Amazon Connect, which enables businesses to have a fully operational contact center that can be operated virtually anywhere. With Amazon Connect, you can have your agents, your supervisors, your managers, and administrators work from home and still be able to perform all their normal contact center activities. We also have Amazon Chime, a collaboration tool that can enable your employees to meet, to chat, and place business calls with a single secure application from anywhere. So they're able to collaborate and instantly go from chat to a call. They can share their screen and invite more people to join their meeting, all within the same application with Amazon Chime SDKs. There's also Amazon Workspaces, a managed secure desktop as a service solution that helps mobile and remote employees access applications they need by delivering a cloud desktop that's accessible anywhere with an internet connection using any supported device. And lastly, Amazon AppStream 2.0, which is a fully managed application streaming service. With Amazon AppStream 2.0, your remote workers or students can access desktop applications they need at any time. We'll get a chance to discuss all 4 services during this session. So let's kick off with the first AWS remote work solution with Amazon Connect for virtual contact centers. CEOs state overwhelmingly that more than any other element of their business, customer experience is the most effective method for creating a competitive advantage. But one area where many companies continue to struggle to deliver similarly delightful customer experiences is within their contact center. Here, we see some common contact center challenges, which are also migration triggers. What you see here answers the question why customers are migrating. So, why are customers migrating? Last year, we commissioned Forrester Research to perform an independent study of customers who migrated to Amazon Connect across all sizes and segments. The study revealed this set of common challenges customers were facing with their previous contact center systems, making it impossible for them to deliver innovative contact center experiences to their customers. One of the challenges they had was having expensive legacy solutions. They had complex pricing and very large upfront costs. Challenging vendor relationships was another challenge, with lack of trust, misleading fees, and overall slow development cycles. There was an inability to scale up or down easily, or sometimes just being difficult to do that. There were also painful, frequent outages that caused lapses in service, lost revenue, wasted agent labor, and excessive troubleshooting. They were also unable to access powerful AI technologies, which were just expensive and most times had very difficult bolt-on integrations. It was complex and expensive to integrate to systems of records, or not possible at all within their legacy contact centers. In addition to all of these challenges for legacy or Gen 1 contact centers, think about all the operational costs companies need to purchase and integrate systems from multiple vendors, with all of these governed by licenses, hardware, telephony trunks, making it difficult and costly to implement and maintain. And now I'm eager to share with you the origin story of how Amazon came to market with a simple to use omnichannel cloud contact center offering called Amazon Connect. If you've ever had to contact Amazon customer support before, you see how this gets interesting. At Amazon, we strive to be the Earth's most customer-centric company, and the success of our future as a company was built on customer satisfaction. About 12 years ago, our Amazon retail business started to see enormous growth, and we were frustrated by all the challenges of legacy contact centers we just talked about. To do this, we needed the right tools to enable exceptional customer experience at scale, but every product we evaluated fell short. So essentially, we built a tool ourselves to use internally. And in March of 2017, which was about 3 years ago, we brought that internal tool to market so that other businesses within Amazon could break free of the same challenges they experience with contact centers. Amazon Connect is a simple to use cloud-based contact center we brought to market to deliver exceptional omni-channel customer experiences that are natural, dynamic, and personalized. And the secret sauce of Amazon Connect is allowing you to integrate with a breadth of AWS services to accelerate the creation of personalized and dynamic experiences with Amazon Connect. It includes all the standard functionality contact center operations teams have come to expect. Amazon Connect comes with skills-based routing, which maximizes the efficiency of agents and the satisfaction of end customers, and also ensures that you connect the right customer to the right agent at the right time. Voice and chat interactions are recorded, making it easy to monitor and improve agent quality. All the common reports and analytics you would expect are available and easy to use, including agent performance, service level, and handle time. Our customers often tell us how much they love the audio quality for calls with Amazon Connect. And all you need to get started with Amazon Connect is a standard broadband internet connection, and the only hardware you need is a USB headset. Your agent can be located virtually anywhere, empowering businesses to offer increased flexibility for work-from-home agents. So now let's take a look at some of the architectural deployment models that we see for contact centers. Here we have an on-premises based deployment, and these represent the majority of existing contact center infrastructure we see today. You notice in the diagram how complex these typically are. And in the picture, all of the blocks represented on the screen are actually physical devices. In most circumstances, on-prem contact centers typically stitch together solutions from various vendors, and they require numerous integrations and frequently involve extensive and ongoing services. In this setup, sadly, customers are locked into complex and expensive licensing and maintenance contracts, and they're also further bound by the upfront expenditure of cost and hardware. This makes it very difficult to adapt if your contact center requirements are always changing. It also poses a challenge to spin up or spin down resources should you choose to innovate or experiment on customer experience in your contact center. Here we see the hybrid deployment model. And you notice in the picture here that the core section is a cloud service with additional on-site things for localization. The hybrid contact centers most frequently use the cloud for storage, interactive voice response, or telephony distribution. They commonly have a lot of one-off integrations that need to be done based on your contact center requirements. One of the challenges with the hybrid deployments is that it increases the anxiety with some contact center companies that are security focused because it increases the complexity of their security posture. Additionally, it doesn't usually address the physical footprint, the licensing, the infrastructure costs, and at best, it just provides a band-aid solution for scalability by using a network interactive voice response. There are also more opportunities for support difficulties in mixed environments because there's no clear ownership of a technical issue. For example, the issue could be cloud team versus the on-prem networking teams. Here, we see the cloud deployment model with Amazon Connect. And this model drastically reduces the complexity that we saw with the on-prem and the hybrid models. Everything you see in the diagram here is an AWS service that's hosted in the cloud, except for the agents and your desktops. This deployment model typically provides the lowest upfront cost, the quickest deployment time, and the smallest footprint for your contact center. Amazon Connect is the only cloud contact center today that scales from tens of agents to tens of thousands of agents. So it's a great choice for some of the smallest customers all the way to the largest enterprise customers. Amazon Connect is built from the ground to be 100% cloud-based. There are no adapters, there are no applets or applications or browser extensions to install because every part of Amazon Connect is available purely in the browser. Amazon Connect can be set up in minutes, and agents can take calls after just a few simple steps. In fact, you can log into the AWS console right now, you can answer a short few questions, claim a telephone number, and be taking calls before I finish this slide. So looking at the diagram here, you see how Amazon Connect integrates with other AWS services that you may be familiar with. I mentioned earlier that the secret sauce of Amazon Connect is allowing you to accelerate the creation of dynamic, natural, and personalized experiences with Amazon Connect by integrating with other services on AWS. And here we can see the power of those services being utilized. Your call center agents use the Contact Control Panel, or CCP, for Amazon Connect, which is provided out of the box, and this is customizable. The Contact Control Panel allows your agents to connect to Amazon Connect using a browser-based subphone over the secure public internet link. You can also integrate your existing CRM systems and your customer data lake with all of your customer information, all using AWS Lambda, which is a serverless compute offering to connect all of that to your AWS backend systems. For example, using Lambda, you can enable your agents look up the caller ID in your CRM system and be able to return the caller's name and account number and use that account number to satisfy customer requests during the phone call. When a call comes into your organization, the caller ID is automatically passed and captured by Amazon Connect. You can configure identity and access management for your agents and supervisors using the AWS Identity and Management Services. You can also store your call recordings and your chat transcripts in Amazon S3, which is our simple storage service, and have access to archive these assets over time. You have access to a wide array of AI/ML and analytics tools. For example, you have access to an AI/ML tool called Amazon Lex, which is the very same engine that powers a popular Alexa device. You can use these AI/ML tools to create better customer experiences like chatbots, to monitor and understand your customer sentiments to effectively train your agents. There's another AI/ML tool called Contact Lens for Amazon Connect, And this allows supervisors and QA managers to better understand the sentiment, the trends, and the compliance risks of customer interactions so they can effectively train agents and replicate success and identify crucial company and product feedback. But overall, you see the reduced complexity in this architecture, and there's a lot of innovation you get out of the box with this deployment model with Amazon Connect. So now that we've seen the different deployment models for contact centers, let's talk about the migration path for your legacy or traditional contact centers to Amazon Connect. So how do you get started? The key to a good contact center migration is a good discovery and planning process to allow your teams work in an agile manner, and you need to first define your goals. So to do that, we think big and start small and go fast. For example, one of the common use cases that we see with most of our customers is that they will often start with migrating internal lines of businesses like a help desk or kickstart a new contact center project. You want to determine the minimum lovable product. And you notice how I said minimum lovable and not minimum viable, because at AWS, we're always looking to delight our customers and not just do the bare viable minimum. So you look for those places to quickly add that value. In this discovery phase, you work backwards with a discovery exercise for all the requirements from all your major stakeholders to ensure that no voice is left out. And this is a good phase to do a proof of concept or pilot to learn and explore Amazon Connect. As a customer, you have access to your AWS account teams and Connect specialized sellers that can also guide you through this phase. Once you develop a plan to have your ideal experience for your call center, the next migration phase is the technology foundation phase. And this is one of the most important phases that customers should implement. Because there's no infrastructure to manage with Amazon Connect, you can focus on building a foundational framework to iterate on right away. And this lack of infrastructure build might be what makes an Amazon Connect migration the most unique, because there's no waiting around for someone to stand up servers or install software. So you might then start with an initial call center flow or a chatbot experience to make for really great first demos and to get all of your stakeholders excited and engaged. As a final note here, as you go through this phase, don't forget to create a playbook for the next stage of migration. You want to keep those lessons learned, the processes you created, designs, any notes on obstacles you overcame, or any other valuable information to allow you accelerate the migration of the next group onto Amazon Connect. Finally, after a successful first discovery and tech foundation phase, you have the launch phase and the innovation phase. With the launch phase, you're ready to move on to even more groups or bigger feature sets. Now you have those lessons learned from the previous phase and a playbook to get started. You're ready to tackle more migrations. It's great at this point, for example, to train your IT team on how to migrate and successfully onboard your Amazon Connect users. If you're working with an IT operations team, you have them come alongside and use the playbook to begin to migrate other groups in parallel. In the innovate phase, agile delivery becomes the foundation for ongoing contact center innovation to better service your customers. With Amazon Connect, you get a never-ending cycle of opportunities to not just migrate new groups, but also continuously improve those that have already migrated as they decide to add new features or add new capabilities that come online in Amazon Connect. So this is an Amazon Connect customer migration story with Priceline. If you're not familiar with Priceline, Priceline.com is an online travel agency for finding discount rates for travel-related purchases such as airline tickets and hotel stays. Priceline Director of Contact Center Technology, Jennifer Featherland, stated that they moved over 1,000 call center agents from office to work from home with Amazon Connect to be able to cope with the pandemic. With Amazon Connect, Priceline was better prepared to provide superior customer service and quickly make adjustments when needed. These are additional training resources for Amazon Connect that are available online. We talked about one group of your remote work users, which are virtual contact centers for your remote call center agents. Now, let's take a look at collaboration tooling for your remote workers, which is enabled with Amazon Chime. You can embed audio and video into your application as a collaboration tool using the Amazon Chime SDK. In fact, much of the same audio and video technology available in the SDK is used in the Amazon Chime Meetings app. And this is the same app that you probably used for meetings with AWS teams, leaders, and technologists throughout re:Invent. Before we dive deeper into how the SDK works, it's worth spending just a couple of minutes on why we built the Amazon Chime SDK. The reality is that audio and video technology can be pretty complex. It relies on multiple integrated standards and technologies. And as builders, you have to plan for communications that can traverse all network conditions while still offering an excellent end user experience. You have to provide applications for your users that can be used from a laptop, a mobile device, or sometimes even a regular phone. All of these requirements mean that there's development overhead, operational complexity, and the extensibility of application may be limited when you're building from the ground up. So, why use the Amazon Chime SDK to build real-time communications to your applications? By using the Chime SDK, you can build faster, letting your teams focus on the plumbing of WebRTC technology while you focus on building out your remote end user experiences. You can take advantage of the Amazon Chime global network with communication services for audio calling, video calling, or screen sharing features, all available in 18 AWS regions without any additional infrastructure investment. This allows you to just focus on your application and your users. The Amazon Chime SDK can scale up or down with no additional work, and it's available across desktop and mobile clients with Android and iOS clients. By using Amazon Chime SDK, you're building on a solid AWS foundation with the ability to extend your apps with capabilities from AWS AI/ML services like Transcribe and Comprehend. So when Amazon Chime SDK was launched, it was essentially made up of three parts: the JavaScript Client SDK, the AWS SDK, and the media services. At a high level, here is how Amazon Chime SDK works to integrate audio and video capabilities into your application. You start out by using the AWS SDK with Lambda in your server-side application to create meeting resources in one of the supported AWS regions. In response, you receive a meeting resource and a set of media URLs that represent the Amazon Chime media services that are used to host the meeting. Your server-side application can then authenticate and authorize each user joining the meeting session and create a corresponding attendee resource by using a unique identifier from your identity system. Each attendee of the meeting is assigned a unique join token that your server application will securely send back to the client application. The client application uses a combination of secure WebSockets and DTLS through WebRTC peer connections to send and receive media to and from other attendees using the media services. So the Amazon Chime SDK takes the guesswork out of adding real-time communication components to your applications. Now, let's take a look at Amazon Chime SDK for messaging. Amazon Chime SDK also supports highly scalable persistent messaging in the Amazon Chime SDK to build chat and other real-time messaging features. There are several Chime APIs for messaging, and these APIs are combined with the Amazon Chime SDKs we just saw in the previous slide, so developers don't have to worry about building and scaling their own infrastructure for messaging. The messaging features can be used alongside with existing audio, video, and content sharing capabilities of the Amazon Chime SDK. And messaging can also be used separately if you choose not to integrate it with video and audio. You can use it in delivery applications or broadcasts because you can allow up to 100,000 members per channel. Here's a quick overview of how the Amazon Chime SDK messaging works. One user on a client-side application is connected to a WebSocket that's provided by Amazon Chime. This user is a member of a channel along with up to 100,000 other users who are also connected to an active WebSocket on their client. When the sender sends the message, the client sends a send channel message API in the AWS SDK, and this message and its metadata are persisted by the Amazon Chime SDK and then fanned out to the recipients. If the recipient does not have the channel open, they can be notified that new messages are available in the channel. And if they're not connected, their client will retrieve the message from history the next time the user connects and loads the messages. Developers can enable sending of attachments using Amazon S3 or their choice of file storage and attach a link to the file in the message metadata. Developers also have the option of turning on streaming export of chat messages through Amazon Kinesis. And this export feature can be used to integrate with services like Amazon Kendra for search or services like Amazon Comprehend to detect sensitive data or profanity, which they can be redacted or archived. Amazon Chime SDK messaging is designed to be highly flexible so that you can achieve the exact experience that you need. I'd like to share with you an Amazon Chime customer migration story with Cerner Corporation. So Cerner is a healthcare IT company that specializes in electronic medical records. The company used the Amazon Chime SDK to rapidly deploy and scale telehealth solutions during the COVID-19 global health crisis, and this solution helped them bring doctors and patients together in the midst of a global health crisis. With Amazon Chime SDKs, they leverage a managed service with Amazon Chime that can support their clients' dynamic usage patterns. Here are some additional resources for you to learn more about the Amazon Chime SDK. Now, I'll hand it over to my co-presenter, John Walker, to talk about additional remote workforce solutions for virtual desktops, application streaming, and well-architected best practices.
Thank you, Jennifer, so much for leading us through some of those remote workforce solutions for migration. Next, we're going to talk about Amazon Workspaces. Amazon Workspaces is a managed and secure desktop as a service solution that helps mobile and remote employees access the applications they need from anywhere by delivering a full cloud desktop solution. So what are some of the challenges that we see for remote workers? The modern approach to work really presents challenges for IT. They need to support many different device types, maintain legacy applications, while also building next generation capabilities. And all of this while providing an easy experience for their employees and ensuring corporate applications and data are secure. Then they also need to drive down costs. Unfortunately, the traditional approaches to supporting end users are falling short. First, many customers are telling us that they've tried traditional VDI and other on-prem infrastructure solutions. With traditional VDI solutions, the IT administrators tell us they're forced to guess at annual demand and to buy hardware for peak needs. And this typically results in overbuy, and it can take weeks or months to complete the ongoing maintenance and infrastructure and onboarding of those new devices. And this can be a real and hard problem. And IT organizations are often caught by surprise when new projects or new groups need to be onboarded and come online. That results in the need to purchase or upgrade hardware and can delay those users coming online. Second, customers tell us that their users are asking for BYOD or bring your own device type solutions with Macs and Chromebooks, and it makes it challenging to securely manage and deliver applications across multiple hardware, operating system, and software configurations. While many customers have moved their data to the cloud, their desktop applications remain on premises on user devices. This increases latency and it makes users less productive as they move data to and from the cloud and to and from their applications. Today, customers also use GPU or graphics processing units enabled laptops in order to run CAD applications like AutoCAD and Siemens NX. So on average, these devices can cost more than $5,000 US. And we have received feedback from customers that they would like to deliver these applications on commodity hardware or reduce their hardware costs and let their workers work from any device. And customers are increasingly trying to support global workforces. It's challenging to distribute those solutions and to estimate demand for solutions across many different physical locations and operating physical device VDI deployments in multiple data centers. Customers also tell us that security is the key requirement and a top priority for them. So as organizations become more agile, how do we protect those corporate assets without choking off employee productivity or reducing business agility? It's the reason that AWS and Amazon have created Amazon Workspaces. Really, this is about simplifying the desktop delivery. Amazon Workspaces helps you to eliminate many administrative tasks associated with managing your desktop lifecycle, including provisioning, deploying, maintaining, and recycling desktops. There's less hardware inventory to manage and no need for complex virtual desktop infrastructure, deployments that don't scale. So we also want to keep that data secure. Amazon Workspaces is deployed within your Amazon Virtual Private Cloud, or VPC, to provide each user with access to persistent encrypted storage volumes in the AWS cloud and integrate with AWS Key Management Service, or KMS, in order to provide the secure storage of those cryptography keys. The user data is stored on, no user data is stored on the local device, and it helps improve the security of your data and reduces your overall risk surface area. In addition, this is centrally managed and scales your global desktop deployment as your needs dictate. Amazon Workspaces is available in 13 different AWS regions and provides access to high-performance cloud desktops wherever your teams get work done. You can manage a global deployment of many thousands of workspaces from the AWS console, and you get to rapidly provision and deprovision those desktops as the needs of your workforce change. All of this while reducing costs. Workspaces eliminates the need for overbuy of desktop and laptop resources by providing on-demand access to cloud desktops that include a range of compute, memory, storage, and graphics resources needs to meet your users' performance needs. Okay, so we've spoken about what Workspaces is and what user problems this solves for our customers. Let's take a look at Amazon Workspaces target architecture. So have a look at the design here. This is a fully managed solution, but you control the networking with your private subnets. The workspaces are going to deploy Elastic Network Interfaces, or ENIs, and you get to control what data comes into and goes out of those workspaces. So we have a fully managed solution. The data isolation and protection is there for your security. And then with scalability, you're able to turn on multiple workspaces in minutes and deploy them to your subnets. And with cost controls, using an option of the always on or auto stop, you're able to really control and dial in how many workspaces, resources you need to be able to allocate for your users. All right, so we talked about a target architecture. We talked about which problems we're trying to solve. Now let's talk about the migration. So migrating your desktop to workspaces really consists of the build out phase, the migration phase, and operations. So during build out, what we want to make sure that we do is to decide what your identity solution is going to be. If you're standing up brand new sets of users, you can use a simple AD in order to implement your identity provider. So AD stands for Active Directory. You can use AWS's Managed Active Directory, or you can use an AD connector in order to connect back to a directory service that exists on premises, in a data center, or in another cloud. You also want to decide your networking solutions. So with networking, you want to lay out your network access. If you have AD connector, it's going to need AD access. So make sure that you've got the open ports back to that Active Directory and probably set in place a virtual private network or VPN connection there. Inside of that security group for your subnet, make sure that you open up the ports to the services that your users need to access. So if that's databases, or if it's accessing special TCP ports, make sure you open those up so your users can access exactly the services that they need. All right, now that we've set up the networking, we've set up the identity, and we're able to bring over your users' identities in order to authenticate into the workspaces, now it's time for you to do the image creation. So during image creation, you'll first launch a workspace and configure it. So use our images in order to create your bundle for your workspace. You can start with a value image all the way up to Power Pro images and choose one of these images per high-level use case for your users. So consider your different user personas and which users you want to deploy this to. Once you create your image, go ahead and minimize the number of images by using Workspaces Application Manager, WAM, which is going to be able to package additional applications to deploy whenever a user logs into their workspace. All right, so other distribution package types also work the way that you're already used to distributing applications onto your desktop solutions. create that image from the workspace and bundle the image with the correct hardware type. You can also use BYOL or bring your own license with Windows 10 desktop licenses. Okay, then you're going to launch your workspaces. Whenever you've launched your workspaces, next you want to figure out which users you're going to bring to bear here. So the user selection is going to be proof of concept users or opt-in groups. Often this is consultants, or I find users are looking at outsourced work or contingent work that's seasonal, and go ahead and turn those on as your first use cases. Then move into other user groups as your needs see fit. Then you want to use correct workspaces sizing. So evaluate memory optimized, CPU optimized, GPU optimized sizing bundles in order to correctly size your workspaces and correctly size your spend. Next, whenever you're migrating that information, you want to make sure that you can access the data that you already have. So what you can do is use Windows Shares and or your WorkDocs Drive in order to make sure that that data is there whenever a user logs into their workspace. Next, let's talk about operations. It's very important during operations to enable those users. So make sure that you're going to train the users and the support desk in order to operate in a slightly new way with operating these remote workspaces in the cloud. With fleet management, make sure that you're evaluating constantly and upgrading to larger bundles or downgrading to smaller bundles as your users' needs see fit, and shift between that always on and auto stop in order to save a little bit of money. Terminate those unused workspaces and you're increasing the value that you're getting out of workspaces. Monitor those alarms and check on your best practices with health checks on network links and on Active Directory using Amazon CloudWatch. And make sure that you're patching, updating, and maintaining those workspaces just as you would desktop solutions. All right, next, let's talk a little bit about a customer story. Amazon.com is an AWS customer. And at Amazon, we were able to burst scale our Amazon Workspaces environment in 1.5 weeks, going from 25,000 running instances to near 300,000 running instances across 8 different regions. So look at that timeline, just 1.5 weeks. And whenever you look at the scale going from 25,000 to 300,000 running instances, that's phenomenal agility that you have at your fingertips. Okay, for a few resources here, you can go over to aws.amazon.com/workspaces and aws.training in order to get access to more workspaces information and in order to get access to some training for Amazon Workspaces. And we heard a little bit about Amazon Workspaces, which is a persistent desktop solution in the cloud. And now I'm going to talk to you about Amazon AppStream 2.0, which is a fully managed non-persistent desktop and application service for remotely accessing your work. So what are some of the challenges that we see for IT to meet end user needs that Amazon AppStream 2.0 fills? So this is a modern approach to work that presents some challenges to IT. First, we need to make sure that we improve the user experiences of applications, all while being able to deliver applications that are becoming increasingly complicated for application delivery. So whenever you think about being able to deliver an application to a Mac, to a Chromebook, to a Windows computer, and being able to do that on assets that may not be inside of a corporate computer deployment. Instead, it may be taken home to someone's home office or to be sitting on someone's kitchen table. Being able to deliver those applications to those users has become increasingly complex as users choose remote working styles. In addition, we still need to have that at the primary forefront of IT users' needs to improve the security of applications while letting those users work remotely. In addition, IT are telling us that they are needing to scale their workforce globally. So being able to provide those same solutions with a consistent application experience, being able to improve the efficiency with which we're delivering the applications, improve the security, and be able to scale globally is a real and hard problem. So this is what Amazon AppStream 2.0 is created for. AWS Apps and Desktop as a Service delivers persistent and non-persistent virtualized Windows apps and desktops as fully managed cloud services at scale. And Amazon AppStream 2.0 is a fully managed application streaming service that allows your remote workers or students to access the applications they need on any computer, whether they're in the classroom, the library, a cafe, or at home. And so what we see is real improvement of the end user experience by being able to stream non-persistent desktops and apps. And the architecture here contrasted with workspaces is a non-persistent by design architecture. This is going to be able to integrate with existing IT storage and identity management solutions. And the approach is really to be able to deliver a fully managed service and be able to deploy this at scale globally with pay-as-you-go pricing. All right, next let's take a look at the target architecture. So the target architecture for this is really going to solve for those same problem sets that we saw IT and users are needing to solve. So for communications, those communications between applications and the data that exists in the cloud are now going to be brought together. So your data will be delivered inside of the AWS cloud, inside of the region that you've chosen in your availability zones in your VPCs. Similar to workspaces, Amazon AppStream is going to be able to deploy your AppStream 2.0 Elastic Network Interfaces, or ENIs, inside of your private subnets in your VPC. And then on top of that, you'll be able to get automatic provisioning with application auto scaling. This is going to be able to automatically scale your applications as user needs increase and scale them back in, importantly, whenever your users' needs decrease. Then for operations, we have AppStream 2.0 Fleet Images, and this is going to be able to optimize what your operations and IT team needs to do. So if you need to, say, update an AppStream 2.0 image because a new patch came in for an application or a new patch came in for the underlying operating system, all you have to do is update one image, and then it's available to all users of that fleet as you deploy that for usage. It's a phenomenally streamlined ability to update your fleet and get those updates rolled out to everyone all at once. As your users log into their AppStream 2.0 streaming applications, they're going to be able to save their data and have it available to them whenever they log back in, whenever they use that application for the next time, by taking advantage of user home folders. That can be deployed in Amazon S3. In addition, you can bring your own cloud drive if you so wish and configure this to connect into your Amazon AppStream 2.0. In addition, whenever you change settings and set them up for your baseline fleet image, everyone's going to get the same default application settings. But if a user is able to change those application settings, likewise, those are going to be stored in an Amazon S3 bucket so that application login over login, the users get a consistent usability for the applications they're using. All right, so we talked about what the target architecture looks like. Let's talk about migrating your applications to AppStream 2.0. And really, first I want to give you an idea of what some of these are. Some of the example applications that I see users have success with are for using a Security Bastion host. Maybe you've got a remote desktop solution that you're logging into to perform secure actions in your cloud. A Security Bastion host, it's also called a jump box. You can have these set up in a way that is non-persistent so that as the user needs it, that AppStream service is available to log into the device, do the security work, be able to log off and have that go away. So it's no longer an IP address that's deployed in your VPC, and it's no longer a target, right? Because it has those security tools on it, it's only there as you need it, as you need to use it. We also see this for 3D engineering, SolidWorks, AutoCAD, Siemens NX, and more, being able to use graphics-intensive processes and being able to get access to that hardware in the cloud without being able to, without the need to provision that heavy GPU-intensive application hardware on users' devices themselves. So there's an easy app import through the AWS Management Console. Just launch an image builder, connect and install your applications, configure them for the default settings that you need, and then set those Windows settings you want your users to have. Then you're going to launch this and optimize it to make sure that your performance is great, exactly what your users need, and test out the application experience and save it. Once you save that image, you can use it for your fleets, assign it to your fleets according to those user personas that we spoke about before. And with AppStream 2.0, that agent software that is on those remote systems can be managed for you. There's no need for you to manage that yourself. So that's an easy way to migrate to the Amazon AppStream 2.0. Let's talk about a customer story. This is Samsung Engineering, And they had construction sites and partners that are located all over the world, including North and Central America, Asia, the Middle East, and Europe. And Jong-Hoon Lee, the senior engineer at Samsung Engineering, said that they were able to save 20% of the cost of purchasing and maintaining on-premises design infrastructure, and they were able to actually improve the efficiency of their personnel to where only one person needs to manage the system. And they had additional benefits. So in addition to saving 20%, they were able to speed up their deployment from months to days and reduce the support staff from 4 to 1 and enable greater customer collaboration. So as they were able to bring on users in different regions, deploying them in each region where they operated once required them to source, deploy, and manage complex and costly on-premises infrastructure for each project. In addition, there were issues with latency that made it difficult for them to be able to bring partners and customers into the project workflow. So for those reasons, Samsung Engineering decided to move its design suite into Amazon AppStream 2.0, and using AppStream 2.0, they were able to virtualize their solutions while providing a fluid, low latency experience, accessible via web browser, and be able to bring in new users independent of where they were located. For some additional AppStream 2.0 resources, take a look at aws.amazon.com/appstream2 to learn more about AppStream. And for training on AppStream 2.0, go over to aws.training. All right, so we looked a little bit at 4 different solutions and 4 different migration patterns for remote workforce. Now let's do some consideration of the well-architected framework. With an AWS well-architected framework, it helps cloud architects build secure, high-performing, resilient, and efficient infrastructure for their applications and workloads. Based on 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimization, the AWS well-architected framework provides a consistent approach for customers and partners to evaluate these architectures and implement designs that can scale over time. So first, let's have a consideration of reliability. With reliability, one thing I want to focus in on, and we're just going to do one per pillar here, is make sure that you're going to manage your quotas. So each AWS service does have a quota. There are soft quotas and hard quotas that exist for each service. As you near quotas, make sure that you're paying attention to the needs of your users, and you can go ahead and provision new quota increases with the service quota tool inside of the AWS console. Or you can open a support ticket using the support resource in the AWS console in the upper right corner. So with Connect, you can pay attention to Connect instances per account. With AppStream 2.0, pay attention to the number of your fleet instances. And with Workspaces, take a look at the number of workspace image types and bundles that you're actually utilizing, and keep track of those with CloudWatch alerts. Next, let's take a look at security. And what you want to do with security is to plan in advance the different personas or user types and how they're going to identify to the system. So pay attention to your identity management system and the credentials they'll use with your onboarding and offboarding, and decide in advance what your identity provider will be, and use AWS documentation for setup and best practices in order to identify those users and for their access control. Next, let's talk about performance efficiency. And again, there's a bit of a focus on users. For users and agents, make sure to pay attention to their enablement. Train your users, your contact center agents, and your support personnel how to use these services in order to optimize the value that you and your teams get from migrating to end user computing on AWS. Next, we'll talk about operational excellence. For operational excellence, pay attention to change management. For incremental changes that you're going to enforce, try to put in place good governance with change management. For updating or configuring contact flows with Connect, for instance, make sure you're keeping track of and using change management. Follow an update and rollback process to make sure that you're streamlining clean change management procedures. With AppStream, for instance, create new images and test them with updates and new applications before rolling them out to your fleets, and also to optimize the amount of performance that your users are going to get out of them. So there's kind of a twofer there with performance efficiency and operational excellence by employing change management here. Next, for cost optimization, make sure and take a look at the self-service options for each of the services that we've discussed today. Evolving beyond the on-premises model of over-provisioning and overpaying, instead, you can take a look at on-demand service technology capabilities in order to enable access to the resources users need at the time that they need them. For instance, being able to provision a workspace by a user, changing that over to an on-demand as opposed to an upfront provisioning system. This can save you and your users significant costs and time. All right, we've talked about the well-architected framework and a key consideration for each. And in summary, we've spoken about Amazon Connect for being able to enable businesses to have a fully operational contact center. We've spoken about Amazon Chime that lets you meet, chat, and place business phone calls with a single secure application from anywhere. We've spoken about Amazon Workspaces as a managed secure desktop as a service solution in the cloud, and Amazon AppStream 2.0 as a fully managed application streaming service. And as you migrate to these, I wish you the best of success. Thank you all so much for listening to Jennifer and me to describe these 4 different solutions that Amazon and AWS are providing for remote workforce solutions and the design for remote workforce solution migration patterns. We wish you the best of luck implementing them and have a wonderful day.